Thanks. This is a real honor to come here and talk to you today. And I recognize the huge commitment from all of you to looking at this. So I've tried really hard to drill down to the basics. And the good news is it's a lot simpler than you probably think it is. The basics, like the root cause of climate change, I'll talk a lot about that. It's actually not too bad. But I'm trying to avoid getting red cards. But if you put one up, that's okay. And there's no yellow cards or anything like that. So my title slide, the first thing, climate is just average weather. When I first got into climate science, I was at the University of Washington as a graduate student and near Seattle. And I thought, well, what is the definition of climate? And it's simply average weather. It's just exactly what you think it is. Like if the summers are getting warmer, the climate's getting warmer. Climate can be rainfall, it can be other things, but it just generally means the average weather. So if there's a trend in the average weather, we perceive that as climate change. The big question I'm going to talk about today is what is the main cause of climate change? I'm going to drill down to carbon dioxide, CO2, and emphasize that as a root cause. I'm going to discuss fossil carbon, fossil fuels. I'm going to tell you that this phrase, greenhouse gas, is just jargon. And I may say it once or twice, but there are better phrases than that, because even the scientists don't really buy the model of the greenhouse. And then finally, I'll discuss one slide of the consequences of warming climate, which you're gonna hit a lot of later. I figured I would start you out with something you may have seen in the news, global average temperature change. This is from year 0 roughly to year 2000. And you can see that the temperatures were fairly stable, got a little bit cooler, and then roughly in the 1800s began to trend upwards. And lately it's just this huge spike. And what I'll go on to say is that spike correlates almost perfectly with rising carbon dioxide levels in the atmosphere. Let's see if I can change. I said I'd emphasize the real basics, and it's important to start with carbon dioxide, a molecule, a carbon atom and 2 oxygen atoms. This molecule is very important. And I'm really glad we have these heat lamps on here, because carbon dioxide is very sensitive to the heat we can feel. So you're sitting close, you can feel that. If we had a big jar of carbon dioxide in the room, those carbon atoms respond. They start heating up from that. And that's the basic physics. I'm not going to dwell too much on it. But instead of greenhouse gases, I'm going to use something a little more understandable. CO2 acts like a blanket warming the earth. So if you imagine like you're cold in bed, you put a blanket on, it traps heat. That's what CO2 does. And carbon dioxide is only 0.04% of the atmosphere. It's not very thick. If a couple hundred years ago you brought all the CO2 down into this room, it would be about 2 meters thick. Today that blanket is 3 meters thick. So the blanket of CO2 is thicker and it's trapping more heat. What if we took away all the CO2? It's a fairly straightforward exercise for climate modelers to do that. If there's no atmospheric CO2 at all, everything freezes over. The temperature would drop from what it is now, about 14 degrees, to minus 18. The equator would freeze over. The Earth is incredibly sensitive to that small amount of CO2. And the main message I want you to have today, you're looking at the root causes of climate change. Basically, 90% of the root cause is fossil fuel extraction. It's the fact that we're getting energy from underground. So the term, what I would use fossil carbon, almost interchangeable with fossil fuels. We're digging up carbon, which is safely buried deep underground, and we're using it to get energy. And when we use that fossil fuel, we release CO2. And CO2 acts like the blanket heating the Earth. So on the left, it's really when you're thinking of climate change, don't start with greenhouse gas emissions, which sounds really vague and kind of nice. It's fossil fuel extraction, fossil carbon extraction. I've got a picture there of an oil well, but it could be coal, it could be natural gas, and other things. And then once it's out of the ground, it's going to become emissions. So the link in your minds should be fossil fuel extraction leading to global warming. So what are these fossil fuels? Probably most of you know most of this. They're the remains of dead plants and animals trapped deep underground. Coal, oil, natural gas have different sources, but the main three, coal, gas, oil, they all contain carbon, and they release CO2 when they're burned. And a little aside here, you may have, you're skipping forward to how we can get rid of CO2 in the atmosphere. CO2 is absorbed by growing plants, but then when the plant dies and the wood is either burned or the plant decays, that carbon is released into the atmosphere. This is part of a natural cycle. The plants grow, they absorb CO2, they die, they release the CO2. That's been going on for a long time. And all that's okay. But what humans are doing is we're saying, oh, we're going to introduce more carbon into the atmosphere, a lot more carbon, and then somehow expect nothing to happen. This is something that was not really known until about 2009. That the most important factor isn't the greenhouse gas emissions, the rate of emissions, how much per year we're putting out. It's the total fossil carbon ever extracted. So the temperature increase of Earth tracks the total fossil carbon. So you add up, starting say in 1800, all the coal, oil, natural gas, carbon ever extracted from under the ground. And that is what's driving global warming. That is the root cause. But it's really important to realize it's the total carbon. So if you stop, basically the temperatures stay the same. If you put more in, the temperature goes up. And this is not well known. Even like reading The Guardian and things, it's not really well spoken of. But this concept leads directly to net zero, which I'll touch on, but I'm hoping you question me about. So in this graph, I'll slow down a bit. On the vertical axis is how much the temperature increases. And it goes from 0 to 2.5 degrees. And on the bottom, I relabeled the axis, the total fossil carbon ever extracted. So if you want to limit the atmospheric temperature rise to 1.5 or 2 degrees, it corresponds to some amount of carbon that's ever emitted. So basically, once you reach this, you have to stop. There can't be any more carbon emitted unless you come up with some means to take carbon out of the atmosphere. And that's the underlying science behind net zero. So the underlying concept is rock solid. There's no way around this. When I read in the paper about net zero, it's never anchored to the actual science. It's always, it's something we're gonna hit net zero, and it's country by country. So the politicians have kind of tweaked this thing, and largely with well-meaning. But the fundamental idea that we have a limit of how much carbon we can put in the atmosphere is rock solid. So I'm going to say 3 very important points to remember about climate change. The first one, the main cause of climate change, the root cause from your diagrams, is extracting fossil carbon from deep underground, which creates CO2. That's the fundamental root cause. Not every bit of it, but say 90%. This one is extremely important and not really realized even by some scientists. CO2 accumulates in Earth's atmosphere. It doesn't go away for thousands of years. An analogy would be like lead poisoning. If you're drinking water that has lead in it, that lead accumulates in your body and until you take certain pills that take the lead out. But the CO2 accumulates. So if you stop putting CO2 in, it still stays high. So this is rather diabolical. It's not like soot from diesel exhaust, which gets rained out in a while, or other chemicals like methane. Methane has a much shorter lifetime, so it would go away in a few decades. But CO2 is a very difficult one. But CO2 is extremely important because it regulates our temperature. And finally, I'll say this, I already said it, but I'll say it again. The global increase in Earth's temperature is proportional to the total fossil carbon we ever pulled out of the ground, to within a pretty accurate measure. So those are my three so far that I can remember. And I thought I'd put up a graph of atmospheric CO2 from 800,000 years ago to today. And as we went through ice ages, the CO2 level bounced around. It was low, it was relatively high. But it's never been above this. And these numbers are from ice cores in Antarctica, so they're pretty accurate. The current level, it's shot up here. Basically, you can't do this. You can't make the blanket that's insulating Earth go from 2 meters to 3 meters thick and expect the planet not to respond. But there's kind of a delay, so we're not perceiving it that much. So here's a nice diagram I found on the internet. Think of the CO2 as like a blanket. On the left, we have the blanket from a couple hundred years ago. A thinner blanket allows more heat to escape. Now, our blanket is about 50% thicker, and it traps more heat. But just like you, pulling a blanket over you, you don't get warm as soon as the blanket goes over you. It takes time for you in the bed to get warmer. So it's the CO2 blanket. So I try to avoid this greenhouse gas emissions, and if somebody asks me, I'll talk about why it doesn't work very well. But so I put these terms here: greenhouse gases, greenhouse effect, greenhouse gas emissions. No, don't do that. Do this. Think of it, if you read greenhouse gases, think CO2 blanket. Greenhouse effect, CO2 blanket. Greenhouse gas emissions, that's fossil fuel extraction. It's not, to me, like a greenhouse is nice. I like greenhouses, and greenhouse gas emissions sounds nice. But fossil fuel extraction is a better, more accurate term. So here's a little cartoon. I'm too hot, no more blankets. So it's not me who came up with this blanket. I've come up with an analogy to rising levels of CO2. It's like rising water in a bathtub. But unlike your bathtub at home, this bathtub has no drain, and it's filling up, and it gets worse. No one is strong enough to shut off the taps and stop putting the water in the tub. Well, maybe there's another way. Oh, there's no overflow drain like your tub has. It's looking difficult. And no one will call a plumber to install an emergency overflow. That's basically the situation we're in today with CO2 rising in the atmosphere. So if you were home and you had this situation, and you didn't want your house to be damaged or ultimately really damaged, you'd run to the kitchen, you'd get pots and pans, you'd get teacups, water glasses, and you'd start scooping the water out and setting it aside. And if you did it fast enough, you would equal the rate of the taps are dropping water, and you'd have no net rise in the water level. But you would run out of water glasses and pans, and you might want to go to sleep, and who's going to do it when you're asleep? So this is my comparison to net zero. So we read all the time in the news, all we have to do is plant trees. Planting trees is like taking cups of water and setting them aside in the bathroom. And then we run out of cups, we go to the neighbor's house, borrow all their cups and pans, and we take those out. This is not going to work as a long-term strategy if the taps are not turned off. It's a really good analogy that's like what the situation is. So stopping the overflow corresponds to net zero, no net rise in water level, which is really difficult to do. So getting back to this, what we say net zero, plant trees. Yes, if we plant trees, they will absorb CO2. But if you work out the numbers of how many trees you'd have to plant, the number is tremendous. And you'd have to plant trees this year for this year's CO2 coming into the atmosphere, more trees next year, more trees the year after that. And it never ends. And you use up all the land on the whole planet. It won't work. It is not going to work. Another very important point. So to limit global warming, we have to cap the CO2 level. The CO2 level, if it rises, the temperature goes up, because we know that the temperature rise is proportional to the additional CO2. In the last line here, it's not enough just to reduce fossil fuel use. It's not enough to say, oh, we're gonna, it sounds good, we're gonna cut gas boiler uses in half. Well, that's good, but it's turning down the tap some, but the water is still flowing into the tub, it's gonna overflow. The consequences of Earth warming. I was asked to say something about this. And I know you're going to have a speaker who specializes in sea level rise. But the root cause of the sea level rise is melting ice that's stored in glaciers and ice caps. If we continue to burn all the fossil fuel available, what's likely to happen is you get a big rise in sea level. Here's a map of Britain, which you may or may not recognize. You can see, Norwich underwater, Cambridge underwater. Not sure if we're underwater here. It's about 60 meters. My house near Exeter, the water will be over the top of the roof. This is what will happen. And so all these people who live in the lowlands can no longer live there. Next one, severe changes in weather, storms, and rain. As a scientist doing climate research, I know this one is very difficult for the scientists to predict accurately. Actually, the news is leading the scientists on this one. We can see that heat waves are becoming more likely, say, in Europe. And this wasn't really well predicted by the scientists. Scientists like to be very careful and cautious in their predictions. And so you might be able to get an article in the paper that says all this bad stuff's going to happen. But if I write that article and it goes out for peer review and other scientists look at it, they're going to go, no, he's sticking his neck out. So the scientists really haven't said this because they have to be really sure it's going to happen. But we see it's happening.
For 2 more minutes, Mark.
Hot regions becoming uninhabitable. If the temperature rises 3 degrees here, well, we can swim more. If you live in the Amazon basin, you're living on the edge of dangerous levels of heat and humidity. If you raise the temperature a few degrees, the human body can't live there. And this can happen across vast areas. Those people will be displaced. If we think the small boats coming from Europe are a problem, it would be horrendous. So large-scale migration. Also, if you care about animals, lions, tigers, anything, it has a natural habitat, and you change that habitat, and you change the rainfall, and you change the plants, they're not going to have a natural habitat to live. They might survive in a zoo for a while. Ocean circulation changes. There are all kinds of feedbacks that may happen in the ocean, where you shut down currents that warm areas. The scientists don't really know exactly what will happen. There's potential for this to happen, but if you burned all the fossil fuel, the temperature might rise 10 degrees C, average over the whole globe. Scientists are not able to predict precisely what will happen, but all the choices are extremely bad. And that includes runaway climate change. If you melt the Antarctic ice cap, you can't refreeze it without, it took like 1 million years to build it up. Yeah, these climate changes are not reversible. So I'm going to stop there and I'll take any questions you have now.